Hello everyone. Now with the second part of performance, which is query performance. When we talk about query performance, we have different types of queries. We have joins, hash joins, loop joins, and merge joins. In addition, of course, to search arguments, etc. So what is about the query? When you think about the query, the main process of the query is to retrieve back information. This is why I need to use it. But according to the normalization, which we had learned previously, there is a chance that part of the data being saved in one table and another part is being saved in another table, and you want to retrieve back the information from both tables and display it as a single record. Let us immediately jump to this example. This example is about now the main joins. Now when I look to this example, I can know immediately here we have two tables and they are being linked through the department ID. We have normalization being run previously on this table and being split into two tables. And through this link with the keys available, I can find my employee is in which location. So now I can run the following query, select. In my select, I will choose employer ID, this one field, location, this field in a different database, and a.department ID. A is table A, this one, and this table is table B. Now I need to mention, because the information is going to be retrieved back from two different tables, so I need to mention both tables. So I have employee A and department B. We have to table AB. If you have another table, then it becomes C, and so on. What is your condition to retrieve back the information? The table A, department ID, which is this one, is equal table B as we configure it, department ID. So when the value in here is matched the value in here, then retrieve back the information of the location for the employee. So for E1, the system is going to retrieve back for E1 Swindon, E2 Liverpool, E3 again Liverpool. This is now what we call it a joins query. With hash joins, the system has two phases. Let us go back to the example which we have it with the joins, and here we have now two phases. The first phase is build phase. With this one, the system is going to search and detect where the match is going to occur between the two tables, and according to that is going to create hash table. Then in the second phase, which is a probe phase, the system is going for each hash to read and compare against the competed hash of the rows in the second table, and the output now is going to be prepared and being retrieved and presented as the query results. The efficiency of hash joins is going to raise in case of these three situations. Data is in large tables or tables have large row size. More input-output processing is required to flush hash table to disk, especially if the disk is not SSD. And the query is frequently used in relational database or LTP, and this is more significant. So just to make sure this one is clear, instead of using a direct joins table and the queries need to be located into memory, they need to be performed, and according to that you might have some slow input output to the disk to write the data. And instead of that, the hash table can be already in there and can be created by a system, and whenever you want you just immediately call it and get the data which you want. And by this, you are not going to have a problem with a lot of processing or input output to be written on your disk. Another type is loop joins. With this one, imagine you have a table A with more than 100k rows, and you want now to search for some specific values. So what you will do, you are going to prepare another table, let us call it B. In B, you will put 10 rows. Of course, in 10 rows, you need to put the main keys. And then the system now is going to check the following. For each row in B, here we have 10. So this cycle is going to run for 10 times. Does A equal B? So do they have the same value for the main keys? If yes, then output the result. Otherwise, just leave it. So instead of go directly and search on the database, you can create another table. And in that table, you can put only the values you are looking for. Then the system is going to match the value between the rows and retrieve back the right information. Now, one of the benefits of following this technique is to order the data to be delivered. Here in B, you are going to sort all the data and order them according to what you need. Then now in each row you will start to find the match row and retrieve back the information. According to the order you already have it on B, now you can retrieve back the information from A ordered. So this is one of the techniques why you might need to use loop joins. The next technique is merge joins. With this one, sometimes you want to merge your tables. So imagine in this example, I have this table, it is smaller in size, and I want to merge it in this bigger table. So what I will do, I'll start now to match the records in A with the records in B. If I find a match, then what I will do, I will move the data which is in A. Of course, it is already in B, that's why I have already the match. So what I'll do, I'll just remove the data which is in A and keep the data in B. And by this, I will free more space and get rid of the old table. I'll keep one bigger table, and then maybe later there is another table with the same data structure and contains data. And again, the other smaller table I want now to merge it with the bigger table, and so on. And of course, you can sort it and create index for it, because this one in time is going to be very large. So you will be able quickly to improve the performance and access to the data which you want. So this technique, we call it merge joins. Now the next subject is search. In case we don't have any index to access directly to the location where my data is, then I need to perform search. And in search, the system is going to scan the table from top to bottom. So if I assume 1000 records, then usually it took about 500 comparison to find the right data for me. And of course, this is inefficient for large data sets, so that's why index is in there to solve this problem. With this example, you can search for all the values greater than 60k, but in addition, you can use arguments like not in and not equal. So with this example, I want all the salary if the salary not equal 60k. So all the records will be retrieved back except this record, because here it doesn't meet the condition and the salary met the 60k. That's all what we have for index. Of course, the idea is going to be more clear once we do the practical sites. Thanks for watching.